like you to take a moment and imagine a world with no colour. Might be a bit dull, filled with lots of blacks, whites and shades of grey, but it's an easy enough world for us to imagine. After all, we can watch Casablanca and It's a Wonderful Life. But now I'd like you to imagine a world with no motion, and that's a much more difficult task. As we age, our bodies become less efficient, and so do our minds. Our visual processing also alters, and this is due to changes in the eyes, but also neural changes in the brain. Visual processing is basically our brain's ability to process and interpret what we see. When a task requires more processing steps, such as driving, older adults tend to show more neural losses, and they're less able to interpret that complex motion. Studies show that as we age, our perception of motion may be reduced, and this can be affected by speed, direction, and motion coherence. And this is what I'll be exploring in my PhD. I'll be undertaking a study to investigate the changes in motion perception and the link to potential age effects. And to do this, I'll be using random dot displays to study the motion-selected regions in the brain. So an observer will be shown a dense pattern of random black and white dots, and this can be modified to show different speeds and also different directions. And this will be used to test a person's sensitivity to these motion elements. We'll also be conducting functional magnetic resonance imaging, or fMRIs, because age-related changes in the brain are associated with the function of the brain rather than the structure of the brain, so how your neurons communicate with each other. fMRI relies on the dynamics of blood flow in the brain to measure brain activity, and in this project we'll be looking at these signatures of brain activity during a motion task to provide a better understanding of the activated and deactivated brain regions and their relationship to behavioural performance. So in a nutshell, we'll be using fMRIs to see how neurons fire whilst the brain is resting, but also whilst completing a motion task. And the aim of this is so that these simple tasks can be brought into eye care settings to predict healthy aging, because our brain ages at a different rate to a chronological age, which is the age that we put down on paper. And where there's a gap between our brain age and our chronological age, there may be an indication of age-related cognitive decline or dementia. And by bringing these simple tests into routine healthcare settings such as opticians, and by detecting dementia early, people will be able to access support early on and provide a better quality of life and hopefully reduce the stigma around dementia.